Hey, welcome to another Math with Mrs. Madsen lesson. Today we are going to be finding and creating polygons on a coordinate plane. So we're going to kind of combine what we did from chapter 3 and with rational numbers and coordinate planes and apply it to polygons and fun stuff like that. So let's get started. The first problem we have here is we see our coordinate plane. And we are asked, says 3 vertices. The vertices are like the corners of the vertex of parallelogram PQRS. So polygons have names, and those names are kind of the points of their vertices, of their corners. So this parallelogram's name is PQRS, and I'll show you what that PQRS is. So P is the corner 4, 2, Q is 3, -3, and R is -3, -3. So it didn't give us the point for S. That's what it's going to ask us. What are the coordinates for vertex S if this is a parallelogram? So let's graph P. P is at +4, +2. Remember that in a coordinate plane, when you have an x-coordinate and a y-coordinate, the x-coordinate is your right or left. The y-coordinate is your elevator. So you first go into the building, then you catch the elevator up or down. So if P is at 4, 2, we're going to go over 4, and up 2. So we're going to put a point right here, and we are going to label that P. Okay, now Q is at +3, -3. So we're going to put a point right at +3, -3. We're going to name that Q. And then R is at -3, -3. So going negative, negative, that is R. Okay, we've got to figure out where S is. And the information we have is that it is a parallelogram. So we can connect P, Q, and R, and then S is going to be somewhere around here, isn't it? Well, we can't just be like, oh, this is S, right? Because if we were to label that, that turns out not being a parallelogram. These two sides are parallel, it's true, but these two sides are not parallel. They would end up connecting down here. So we got to be a little more strategic in figuring out where S is. Okay. Well, we can figure out where S is. We can count. If this is 1, 2, 3, 4, 5, 6 units away, then that means this will also be 6 units away on top. 1, 2, 3, 4, 5, 6. So if we were to put S right here and connect those lines, do we now? Yes, look how beautiful those blue parallel lines are. So that's one option to figure out how to make them parallel. The other way you could figure out how to make it parallel is to take the Q and let's go 1, 2, 3, 4, 5 up and 1 over. 1, 2, 3, 4, 5 up and 1 over, and we'd end up at that same spot. So the same kind of turn, twist, angle, whatever. Those are 2 ways you could do it. So it's asking us what are the coordinates for S? Well, S is at -2, and then we went up 2. So -2, +2. And then the next question we have is, what is the area for this parallelogram? Well, we're going to remember the area is just base times height. We already counted the base, right? The base was 6. And then the height, 1, 2, 3, 4, 5 was 5. 6 times 5 is 30. We're going to make sure we do square because it's area. And then units because it doesn't tell us if it's feet or inches or miles, right? So those are the 2 answers for that first example. Another thing that you're going to be asked to do this chapter is to graph triangles, graph the polygon, and then find the length of one of the sides. So let's graph this triangle. We know A is at -1, 3. Make sure that we put A there. B is at -4, -2. And C is at 2, -2. All right, so here is our triangle. And the question was, what is the side length BC? So BC, we can just count, right? 1, 2, 3, 4, 5, 6, and say it's 6 units. Or we can remember that if we take -4, -2, and 2, -2, we can remember that trick where we can be like, all right, we're going from a -2, -4 to a +2. What's the distance between -4 and +2? Well, it is 6 units away, right? You kind of take the absolute value. There's 4 units right there, 2 units right there, add them up, and you get 6 units. So both of those strategies might work for you. Another thing that we're going to be asked to do today is to classify the quadrilateral, classify whatever shape it is. Classify just kind of means to name. So let's name this little, looks like it's a quadrilateral. Yeah, right, because it says quadrilateral. Plus there are 4 points. So let's get to graphing it or plotting it. -2, -3, that's W. -2, +3, that's X. +3, +5 is Y. And then 3, -3 is Z. So you're going to make sure you connect the dots in alphabetical order. We don't want to go like rant, 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 right? That's not the name. It's W, X, Y, Z. Make sure you do it in alphabetical order. W, X, Y, Z, and connect the dots. Ooh, what do we have here? It's definitely quadrilateral. If I were to like twist it, I could tell. Well, first of all, I know it's not a square. And it's not a rectangle either, right? Because these 2 lines are not parallel. So we can't say parallelogram or rectangle or square. So I'm going to call it a trapezoid because we have the pair of parallel sides, but then, like we saw, these are not parallel. So because there's only one pair of parallel sides, we're going to call it a trapezoid. Boom, just like that. So Andrew is drawing a sketch of the garden he is going to plant. Line segments JK and KL are 2 sides of parallelogram. All right, we got to find another parallelogram. Now would be a great time to pause it and see if you could do it on your own because the very first problem in these notes was a parallelogram. Okay, so I'm going to see that there's 1, 2, 3, 4, 5 units between J and K, which means there'll be 1, 2, 3, 4, 5 units between L and M. Does that look parallel if I drew it correctly? Yeah, it looks pretty parallel. The other way that I taught you is let's go 1, 2, 3, 4, 5 up, 1 over. 1, 2, 3, 4, 5 up, 1 over. And I see that they are parallel that way. So the coordinates for M are -1, -3. Here's a triangle that we're going to find. The length of JK. Now, I've taught you how to find the distance without even having to draw it. So here you could draw it, of course. But if it just wants a length of JK, just kidding, JK on that, JK, we're actually going to do it. What is the distance between the -3 and the +5? -3 all the way to +5 is 8 units, isn't it? But if we want to try it, let's make sure -3, -3, -3, +5, and +5, +2. Here is our triangle. Oh, guess we didn't label it. J, K, L. So it wants the distance JK, 1, 2, 3, 4, 5, 6, 7, 8. It is 8 units either way. All right, the last one is for you. The points -1, -2, -1, 3, and 4, 3 are 3 vertices of a square. What are the coordinates of the 4th vertex of the square? That is all you. Figure that out. You can use one of these grids that I made, that I put on for you. Think you got it? All right, let's figure it out. -1, -2, -1, +3, +4, +3. If I wanted to make it a square, boom, boom, where would it have to be? Have to be at +4, -2, which is B. Boom. Have fun at your practice and enjoy drawing polygons on a corner plane.